This is topic 2, recording 2. I'm going to cover graphing and types of distributions. Or maybe just graphing. Okay, graphs. So we're going to talk about nominal graphs for nominal ordinal data. So remember we talked about that last week. We use bar charts, pie charts. We're going to be talking about graphs for interval ratio data, such as histograms, stem and leaf. We're not going to cover stem and leaves in this course. Okay, and then we're going to talk about breaking it down by group. Okay. And then we're going to talk about graphing relationships with scatter plots. And finally, talk a little bit about good and bad graphing. Okay, so for nominal and ordinal data, we're going to want to use either bar graphs or pie charts, right? The idea is you want to represent the number or percentage of people in each category. So that's just the frequency of them, right? Remember I talked about how we really use frequency distribution tables for categorical data, right? Nominal, ordinal, nominal, we saw sex, and then we saw political orientation, which is ordinal, right? So sex is nominal, political orientation is ordinal in that example. Another example of nominal data is religion. So here's a bar graph, right? It just shows the frequency, the count of how many people in the sample said they were Protestant, Catholic, and so forth. We could also present it as percentage, and you have that option in SPSS as well. So you can have that title. You'd want to remove that title for APA style, but SPSS spits it out like that. Okay, then you have the x-axis, where you have the religion and the category names, right? And then your y-axis, which just is frequency or count. And that's what you're measuring, how many people, right? Here is a bad chart, right? So this is exactly the same data, but you'll notice that the y-axis has a terrible scale, so it makes it, you can't really tell the differences here, right? Here's a bar chart with percent, so the same idea. You could also use a pie chart, right? Very colorful. And again, it shows the count. You could either do counts or percents for each slice of the pie. Okay, so what about interval ratio data? Interval ratio data is continuous rather than discrete. Bar and scatter, bar charts and pie charts are good for discrete data, which is usually nominal or ordinal. Okay, for interval ratio, we're going to use histograms. We can also use line graphs, stem and leaf. Okay, we can break things down by category. So for example, maybe we're looking at grade point GPA, which is interval ratio data, and we want to look at it separately for men and women, right? Okay. Since these are not discrete or categorical, we cannot use bar or pie charts, and we'll see an example of why not in a minute, right? So here is a histogram, right? IQs of 36 randomly selected Victor Valley College students. This is from before, right? So what SPSS does, or you could do it yourself with, pen and pencil, is you make bins of scores. So, okay, so here, this shows all the scores that were between 110 and 100. So there were two. This bar in the histogram represents all the scores between 110 and 120, and there were 11 and so forth, right? So each bar represents scores within a certain category, which we call bin, right? A range of scores. Now, if we did this as a bar graph, each score will be shown as a separate bar, okay? And which really doesn't tell us much. It's not very useful, right? If we do it as a pie chart, it's very beautiful, but it doesn't give us much of an idea of what's going on. Okay, so what about relationships? Scatter plots allow you to visually inspect how two variables are related. It shows the pattern of the relationship. Now, right now, I want to introduce the term to you as an outlier. An outlier is just a data point outside of the general pattern. And we're going to talk a lot more about that later. So let's look at an example. What about moral agency, which is the extent to which people believe they have control over their morally relevant actions, and integrity? Are people who report high scores in one likely to report high scores in another? Seems likely because they're both about morality, right? So we can have SPSS create a scatter plot for us. And we can see that indeed this upward slope indicates a positive relationship. Remember, we talked about that last week. Okay. What about outliers? Okay, those are the data points that do not follow the general pattern, right? So that one, for example, okay? Those two, right? They're not following the general pattern. Another one, correct? Okay. We're not going to cover polygons in this unit. Okay, let's look at some more examples where we split data by categories. We're splitting integral ratio data by nominal or ordinal data. Okay, so variables, I should say. Okay, so here we have attendance and, okay, so this is grades, right, in a statistics course. So the people who attend the most, right? We have one category attend most, another category rarely attend. And this is percent for grades. So we can see people who attend the most are getting all C's or better, and people who rarely attend vary between people who are brilliant and get A's anyway, and people who fail because you really need to come to class, right? But what if we use, instead of percent, letter grades? Okay. Letter grades are ordinal data, so we can use bar charts. But with a bar chart, we can still split it up in categories by attend most and rarely attend. And we can see this might be a little bit more informative because we're not so interested in, as students, as whether we get a 95 or a 75 or an 81. We really just need to know if we get an A, a C, a B, an F, or a D, right? Finally, I want to show you a couple of graphs we won't actually be using in this course, but it's interesting to see. So this shows you percent of women receiving PhDs by concentration and by year over here, right? So we can see these are people who receive a PhD in experimental physiological cognitive, and these are all other majors, right? And we can see there are fewer people in each year that receive PhDs in experimental physiological cognitive, right? Now we can present these same data as a bar chart. And sometimes bar charts are more interesting and easier to understand, right? So we can see here, it clearly shows that the number of people receiving PhDs in experimental physiological cognitive is consistently fewer than those receiving PhD in other concentrations, but we can also see it increases. So in this sense, sometimes a line chart is better than a bar chart. Remember, graphs are all about presenting data visually in a way that is easy to understand. So that's our main goal. Okay, I'm going to pause here and then do a third video.